Find a vector function r of t that represents the curve of the intersection of the surfaces z is equal to the square root of x squared plus y squared, and z is equal to 7 plus y. So the first steps to solving this problem would be to set both of these z functions equal to each other. We can have the square root of x squared plus y squared is equal to 7 plus y. And we can say that they're equal to each other because they're both functions of z. Now, if we square both sides, we're going to be left off with x squared plus y squared is equal to 49 plus 14y plus y squared. And remember, for that part, we're just using our identity. So a plus b squared is equal to a squared plus 2ab plus b squared. So that's how we got the 49 plus 14y plus y squared. So now if we simplify this further, let's move this y squared over. So we're left off with x squared is equal to 49 plus 14y. That y squared is going to go away. But I want this in terms of y. So if we're going to solve it for terms of y, we're going to move that 49 over. So we're going to have 14y is equal to x squared minus 49. And by isolating the variable, we'll be left off with y squared is equal to x squared minus 49 over 14. But recall, we're looking for a vector function of r of t. So we need it in terms of t. And right now we have our function y in terms of x. So if we establish, let's say, let x equal to t, now we can just rewrite this as y is equal to t squared minus 49 over 14. So let's just make a little note on the side of what our functions are. So we'll have x is equal to t, y is equal to t squared minus 49 over 14. And now we just need to find our z. So what's our z? Since one of our functions of z, 7 plus y, already has y by itself, let's just use that one. It'll be more simple to solve than the x squared plus y squared one. So we'll have 7 plus t squared minus 49 over 14. So now if we want to combine the 7 with our other fraction, we have to find a least common denominator between those two terms. So the least common denominator between those both is just going to be 14. So 7 times 14 is 98. So 98 over 14 is the same thing as 7, because if we reduce this, it will become 7. But we don't want that, so we'll have 98 plus 14 plus t squared minus 49 over 14. Negative 49 plus 98 is going to be positive 49. So now we're just left off with z is equal to t squared plus 49 over 14. And so that's what our z is. So let's write that. And now that we have all the pieces that we need to find our vector function, let's write it out. There are two forms for a vector function. We have our letter form, so we'll have I, j, k. And then we also have our brackets like that. So let's just write both of them so we're familiarized with both. So our first function of r of t, if we have our x is equal to t, it'll be t I plus our y is t squared minus 49 over 14. So we'll write that. J with the vector hat plus, and then again, just plug in our z value of t squared plus 49 over 14 k. Or if we were to write it with our brackets, it would just be t squared minus 49 over 14, and then t squared plus 49 over 14. And then these two are both valid solutions.